Welcome everybody to GraphQL is for client developers, not client applications. So before I dive in, let me set a little bit of context. My name is Michael Bleigh, and I'm an engineering lead on the Firebase team at Google. If you're not familiar, Firebase is a platform of developer tools that helps people build, deploy, and monitor web and mobile applications. And I have never used GraphQL in the normal way. I've never built an application, put a GraphQL API in front of it, deployed and maintained that application in production. I've played around with it on my own, but I sort of came at all of this from a different angle because I came at this from the lens of building developer tools, and specifically building Firebase Data Connect, which is Firebase's newest product, and it's a backend as a service that uses GraphQL to interface directly with the Postgres database. We launched this into private preview a few months ago at Google I/O. And so I've been working on this for a couple of years. And in that time, I've started paying more attention to what's going on in the GraphQL community, the Twitter drama that flares up from time to time. And there are a couple things that I saw that sort of live rent-free in my head now. One of them, but before I talk about that, let me first talk about why Firebase chose GraphQL in the first place. GraphQL is really terse. With GraphQL, you can express a complex schema using relatively few characters really quickly. It's easy to read, it's easy to write. You can learn most of the GraphQL specification in an afternoon. GraphQL is strongly typed and language agnostic, which is really important to Firebase because we build across web, iOS, Android, Flutter, and more platforms. GraphQL is customizable using directives. It has a large community. I mean, we're at GraphQL Conf right now. It's battle-tested in production by large enterprises, and it's really powerful. GraphQL just generally has the ability to craft really expressive, really powerful queries and do a lot of things with it. But again, we're building a backend as a service to connect to a Postgres database using GraphQL. And a couple of years ago on Twitter, there was a conversation, and this came up as a meme, which says GraphQL belongs between the client and the server, not the server and the database. And I've spent probably way too much time thinking about this meme because essentially I was doing exactly what this told me not to. I was building a product whose purpose was to connect GraphQL directly to a database. So, it made me question, am I doing the wrong thing? Are we taking the wrong approach here? Is this the right way to go about it? And then more recently, back in May, there was a blog post, why after 6 years I'm over GraphQL. This blew up in the Hacker News sphere a little bit. And it was a developer who talked about some problems that they had with GraphQL around authorization, rate limiting, query parsing, performance, coupling, and complexity. And again, I sort of started to question, like, am I doing the right thing? Is this the right approach? Was GraphQL the right choice for our new product? But all of those great things about GraphQL that I mentioned are still true and remain true. And so the question is, what's the root cause of these problems? And is there something that we can do about it that makes it workable? And I think that fundamentally those problems come down to a question. Is GraphQL too powerful? Now, I don't mean this in the sense of like, you're at an interview and the interviewer says, what are your biggest weaknesses? And you say something like, I think I just work too hard and care too much. When I say, is GraphQL too powerful, what I really mean is that power is great, but power has to be wielded responsibly. And so how do you wield GraphQL? Because some of the things that make GraphQL great can also kind of bite you. And these are what I call the curses of GraphQL. So first is the curse of normalization. In GraphQL, you can define a normalized data model. So you can have a simple type like a user, and that type can have fields that are resolved across different audiences. So maybe I have an ID and a name and like a profile image, and anybody can read those. I have an email and a social security number, and only the user should really see those, or maybe administrative staff. And then there are some internal fields like a reputation score or the experiment groups that the user has opted into. And none of the public users should ever see that, but it's for the team. It's amazing that GraphQL lets you put all of this into one place, and then you can write queries. You can say, well, for the home feed, I only need that public-facing information. I don't need to fetch the rest. For the settings page, I need to fetch all of the information that the user has access to, but I still want to keep that internal stuff out. And for the support team page, I'm going to fetch most of the information, but I'll leave the SSN out because that's private, personally identifiable information. I don't want my support team to see that. And this is really powerful, and this is an awesome attribute of GraphQL until you need to implement authorization for it. Because now you have this complex intermeshing of various audiences, each of whom may need access to certain fields but not other ones, and you end up just implementing a lot of complicated logic around who has access to what. And I think that the thing that I dislike the most about this is just that you have to kind of think about the entire universe of possible accesses at the point of your field. So you have to say, who is every possible person who might need access to this field and every possible person who shouldn't have access to this field, and let me define up front the rules that allow that access. So this is workable, but it's not my favorite thing. And that's kind of why this can become a curse. Another is the curse of coalescence. So GraphQL is awesome at coalescing multiple requests into a single request. You avoid request waterfalls, you avoid that server-side round trip, and you bring everything into one request. If you're doing something like a homepage query where you pull some items from a feed and you pull some upcoming events the users subscribe to, and maybe there's a notification banner, like this is great, 10 out of 10, chef's kiss, no notes, I love doing stuff like this, because it just makes my job as a developer easier. I'm bringing together multiple things that I need at the same time anyway. But at the same time, I can construct a query that looks like this, where I find friends of friends of friends of friends of friends, and then I just ask for the name, and now I'm querying 2 billion rows in my database, and everything crashes and my service falls over. And again, you can mitigate these kinds of problems. You can do things like implementing a maximum depth to your queries. You can have complexity scores. There's lots of things you can do. But you have to think about all of that up front. You have to guard yourself against potential misusing queries. And so ultimately, I think this boils down to the curse of queryability. GraphQL is a query language. You can construct really expressive, arbitrary queries against a type schema and come back with lots of different things. The surface area is enormous. And what we like to think about is that we have a back-end developer, and the back-end developer builds a GraphQL API. And we have a client developer, and the client developer builds an app that uses the GraphQL API. And we have an app user, and the app user consumes the app, which calls the GraphQL API. Everything is rainbows and sunshine. This is exactly what we think about. This is exactly what we want to happen. The problem, though, is sometimes you don't have an app user. Instead, you have a bad actor. And the bad actor says, hey, I noticed this app is using GraphQL. I'm just going to go ahead and toss that app in the garbage can, and I'm going to go straight to the API, and I'm going to try to see what I can break. And that could be trying to exfiltrate sensitive data. That could be trying to inject bad data. That could be trying to just denial of service your server by querying too much. There's a bunch of bad things that they can try to do. And this is a problem because we have a mix of personas here. We have a back-end developer who's trusted. We have a client developer who's trusted. And we have an app user who is definitely not trusted. Even though 99.99% of your users are going to be lovely people who just want to tap around on their mobile app, that 0.01% can really wreak some havoc. So how do we break these curses? What is the mechanism for solving this problem? Well, I've already talked about some of those. You can do query complexity scores and per-field authorization and maximum query depth and multiple graphs that are exposed to different clients differently and per-field rate limiting. You can pile all of these things up to mitigate these problems, and that's by and large what people do. But let's think about who is responsible for doing all of that work. It's definitely not the app user. They're just using the app. They're not going to do all of this work. And the client developer, even if they'd like to help, they don't really have an opportunity to help here because they're just a consumer of the API. They can only handle what, like, they're just using it. And so ultimately, all of this complexity falls onto the backend developer, who now has to think about this entire world of potential problems and misuse of their API, and they have to build all these complex solutions to solve that. And as somebody who likes building backends, that makes me a little sad. I don't want to do all that work. And why is this such a problem? And I think that it's largely a problem because we are putting two people on equivalent footing. We are putting the client developer and the app user or a potential bad actor as basically peers in this system because they both have equal access to the GraphQL API. Now, the app developer knows the internals and is going to know which fields exist. Most people disable introspection in prod, right? But by and large, an app developer is accessing the API the same way that a bad actor would. And that's not what we want. We don't want the bad actor accessing our APIs. So it seems like what we would really want is for the backend developer to provide a GraphQL API, for the client developer to do something, question mark, for the app user to have an app, and then the app talks to this new layer that's in between. The new layer talks to GraphQL, and this lets us separate out trusted and untrusted access. And by doing this, we solve a big problem. Because now the app user can't bypass this middle layer and go straight to the GraphQL API. They can't construct arbitrary queries that are terrible for performance, that are terrible for your application, because they can't construct arbitrary queries at all. Everything goes through this middle layer. Now, you might have heard of something called trusted documents or persisted queries. And yes, that's pretty much the concept here. The idea is that you define a set of allowed queries to your application, and only those queries may be executed. Nothing else can be executed. That's usually done by sort of taking a SHA hash of the query and sort of checking it against a pre-flighted list. And that is definitely a solution here. So if nothing else, if you take nothing else away from this talk, look into trusted documents and persisted queries and consider if you're just building a first-party GraphQL API, look into this as a possible solution for making your API more secure. But when we were building this product for Firebase, we were thinking of it a little bit differently. So let's take a look at these queries, and then let's take a look at the wire protocol for GraphQL, how this actually gets sent over HTTP. I post to a GraphQL endpoint. I include an operation name, any variables that I want to set, and then I send the query document along for the ride. And if I just make a couple little edits here, if I change GraphQL to /API, if I remove the query, then I get something that looks like this. And this looks kind of like an RPC protocol. Remote procedure call, if you're not familiar, that just basically means there's a remote endpoint, you can call it with arguments, it returns a response, and you've agreed on some protocol for that. And so as we started building this product, we asked the question, what if your query document was secretly an API specification? And we call that query-defined infrastructure. And that's at the heart of the Firebase Data Connect product. And so let me take just a minute and show you a little bit about what we mean by that. So this is just a really simple little demo app. And here is my type schema. It has two types. I have a user and I have a post. And a post belongs to an author that is a user. Posts are also moderated. And you can see that each one has a table directive. So this means that each of these is represented by a table in Postgres. And with Data Connect, your GraphQL schema actually drives your Postgres database. So if I added a new field here, say favorite animal, and I save that, and then I pop over and I take a look at my schema, you can see that indeed favorite animal shows up. If I delete that back out, save, it's going to drop that out of my database. So with Data Connect, we have a GraphQL schema that is actually driving your database schema. And it does more than that, because based on these types, it generates a rich query layer. So I can type a query. Whoop. There we go. And I can see with autocomplete, I can query users, and let's say that I want their favorite color and their name. And I can also do sort of rich SQL-style filtering, so where, and let's say name starts with m. And I'll just run this using the VS Code extension that we built. And you can see that I've got users whose name starts with M and their favorite color and name. So this is just GraphQL, right? Like, we're just building GraphQL. The only thing that we've done here is we have built a GraphQL to SQL translation layer that we automatically generate for you based on your schema. I could have a whole talk about this, but that's not what this talk is about, because this talk is about a different part of Firebase Data Connect. It's about what we call connectors. So you can see in my files, I have this connector directory that has 3 files in it: admin, post, and user.gql. And these represent the operations that I actually want to use in my application. So for post, I have create post, delete post, and list posts. For admin, I have approving posts, rejecting posts, and I have a moderation queue query that loads a bunch of stuff. And for users, I have something that automatically updates when they sign in, and I have a get profile. So these are just the operations that I need to use in my app. And I've written them as GraphQL files in this connector directory. And so then how do I then use those in my application? So if I flip over to my React app, you can see, for example, fetch posts, and it just says await list posts, and I pass in a Data Connect instance. And that seems a little too good to be true, so let's take a look at what this actually is. This is automatically generated SDKs for the web based on my defined queries in the connector. Now, obviously, lots of people are familiar with using GraphQL to generate code, but what's different here is that actually these SDKs are not GraphQL aware at all. These are essentially RPC SDKs that are speaking that protocol. They're not aware of the query structure. They're not aware of anything about GraphQL. They just know that they have a specific structure for their requests and their responses, and we generate everything for it. And you'll also notice that on these queries, I have these auth directives. And that allows me to, at a per operation level, say that, okay, this operation requires a user, whereas the admin operations require a user with an auth.token.admin equals true. This is using the cell expression language created at Google, and it basically just lets you inject little expressions into it. And then the last thing that I want to highlight is what we call server expressions, which is where you can actually inject trusted server values in an untrusted context without having to write server code. So you'll see here that when let's take a look at user create post, or at create post. So I'm inserting a post. The author is a unique ID expression of auth.uid, and that means that that will inject the current user's ID into this context and use that as the value. Notice it is not passed as a variable. It is sort of hard-coded into the schema, into the query syntax. And that means that this can't be tampered with. So if I look at my app, it's just a simple list of posts from different users. And let's say that I'm this user and I say GraphQL stinks. Bummer. Then I switch over and I am in my moderator view. And I don't see the post right away because this list posts automatically filters out unmoderated posts. And so I'll go to my admin moderation queue. These all look good. That's fine. Oh, GraphQL stinks? No, that's not true. Reject. Done. So, this looks like any other application, and nothing's that special about it. But what is kind of special is the fact that I am querying against a schema that is capable of doing terrible things to my database. I could literally write I can do that right here. I could say mutation, post, delete many, all true. And if I ran this, then all of my posts are toast. And so that seems terrifying. Except by introducing this layer where we essentially turn GraphQL into an RPC protocol, it's not anymore. Because unless I exposed an operation that performed this action on my GraphQL API, no untrusted client is ever going to be able to do that. So we call this a connector. And it's also been called trusted documents, and it's also been called persisted queries. But we think of it as connecting an untrusted client to a trusted GraphQL API. And what this does is essentially generates an API endpoint that is secure, parameterized, strongly typed, and you don't have to write any server code. This is all sort of done for you. And it also generates a client SDK for you to consume that API endpoint that is strongly typed, has narrowed results. So, if you remember, there was a reputation score in experiment groups. That doesn't show up in any of the types of the generated client SDK because that didn't show up in any of the queries that I wrote. And so you have the ability to sort of narrow the scope of your clients to only what the application is concerned about. And fundamentally, this lets us drive a change from a schema-centric to a query-centric model of thinking about GraphQL. In the schema-centric model, your entire schema is an attack surface. Somebody can craft arbitrary queries that you have never thought of that might do terrible things to your servers, inject bad data, like exfiltrate good data, like lots of things could happen. In the query-centric model, the only thing the client can do is tamper with the variables that you've exposed in your operation. In a schema-centric model, any query could be a bad actor in disguise. You don't know who's issuing it. In the query-centric model, all of your operations are defined up front during development. You know exactly the entire scope of what's possible to be executed against your schema. In the schema-centric model, it's often unclear where to optimize until after it's already live. With the query-centric model, you can analyze everything statically up front. You can do complexity analysis based on just the pre-saved document before you ever deploy it. And in the schema-centric model, you have complex rate limits where you might have to say, okay, this field needs to be limited to this, or maybe it's only bad when it's combined with this field, and there's just like the combinatorics of that make my head explode. In the query-centric model, you can just think about like, I don't know, how many times should a user be able to query the home page? And you could set your limits based on that. You can think about things at the operation level. And fundamentally, connectors let you reason about GraphQL like it's server code. And for me, at least, this is like an incredibly freeing thing because there's this paralysis that I get when I think about what are all the weird ways that somebody could come up with to construct a query that I'm not gonna like. And it just simplifies that. It shrinks the attack surface to this tiny little thing of just what are the specific operations that I have exposed. And so even though most of what I've been talking about is sort of a security feature or could be considered like a security model or approach to GraphQL, I'm in the developer experience track here. And why am I in the developer experience track? Because for me, this security model makes the developer experience with GraphQL so much easier. Like it's so much off my shoulders as a backend developer to not have to worry about the entire possibility space of every query with every field that I add, with every new resolver. So as you've probably guessed now, that question mark, that mystery layer, is Firebase Data Connect. And because that translates GraphQL into this sort of more RPC-like, more constrained API, that lets us do the very thing that was talked about as being a bad idea. We can have our GraphQL talk directly to our database without a server layer in between that's telling you what you can and can't do. And it's safe to do because only privileged users with administrative credentials have access to the full power of the GraphQL API. And untrusted clients only have access to that limited set of operations that you've exposed. So before, we had our backend developer, and they had to deal with all of these problems kind of by themselves. But with the model of a connector, the client developer gets in on it, and you can work together. And so the backend developer is worrying about providing the data that's being consumed by the client developer. You still have to worry about N+1 queries. Sorry, that doesn't go away. And you optimize for the use cases that are actually in the application. But the client developer also can worry about some of this. They can worry about making sure they're careful in field selection so that they're not overexposing data. They can select the authentication and authorization that's right for each individual endpoint, because that's really where it's easiest to reason about. If I'm saying, like, show me the home page, then I can think about, okay, like, who should be able to see the home page, instead of who should be able to see field C on type A that's exposed in the home page, but also in 8 other locations. And the client developer is responsible for being reasonable about query complexity. If you did the friends of friends of friends of friends query as a client developer, you're still going to break your app. But at least this time, you can probably catch it in CI instead of in the wild when somebody just issues that query randomly. And so these problems don't go away, but they are greatly diminished by taking this model. We've used this to build Firebase Data Connect, and right now, Firebase Data Connect is just for talking to Postgres. We've got big plans and future things that we want to do, but I also wanted to make this talk just because even if you don't use any Firebase products, even if you just use persisted queries or trusted documents or whatever you want to call it, whatever tool is providing it, I think that that security model is incredibly freeing for GraphQL, and so I thought it was worth sharing. Because GraphQL is great for client developers, not client applications. Thank you. And I've got a couple minutes here, so I'm happy to take any questions. Yeah. So the question was, does the client look like it's talking to a GraphQL endpoint or to a REST endpoint? Our current implementation for Data Connect is that it is essentially compatible with the GraphQL wire protocol. We just omit the query part of the wire protocol. And so we made that decision kind of deliberately. But we have thought about, what if you could add annotations to a query or mutation that gave it an endpoint path and a method name, and now you're essentially constructing a REST API out of a GraphQL query. So those are things that we've thought about, but at the moment it is similar to the GraphQL wire protocol. Yeah?
How central is that auth directive to sort of the whole story?
So for us, it's very central because the layer between the server and the database is not written by hand. It's not written by the user. So there's essentially no access control other than just whatever the database or whatever the server has been granted access to within the database, the server has access to. So for us, it's really important because you have to define that on every operation. If you are just using the sort of persisted query model and you have authorization code in your resolvers, then it's still just as secure as that. It's the same thing. It's just that you can't construct arbitrary queries. So I would say that having these sort of custom auth directives on the operation, it kind of depends on how much you want to use this connector model as a security model versus just using it as an enhancing security feature to reduce attack surface. Does that make sense? Yeah. So I think that it would be, the question was does this become a leaky abstraction because now you're sort of applying authorization at multiple points? And I think off the top of my head, I would say that it's probably similar to how field level authorization works now, where it's just you're actually applying authorization at a bunch of different levels, and at each level when you apply that authorization, you're deciding, am I throwing an error when this gets hit by somebody who shouldn't do it, or am I just nulling it out and returning a partial response? And I think it's sort of the same thing, except for you're probably throwing an error. So I think it is, there are ways that these things compose together and could run into conflict, but I think it's sort of no different than how authorization works otherwise. Yeah. So the question, it was essentially queries live with in the client code. And with this model, don't you have to essentially ship all of your queries to the server in order to have this work? And the answer is yes, kind of, but you can actually separate these out a little bit. So you can have, within Firebase Data Connect, for example, again, this is, I'm sort of talking about a pattern, and I don't have an open source library to share. I just have the product that we've built. But in Firebase Data Connect, the schema and the connector are two different resources, and they have sort of independent permissions. So you could have somebody you could say that developer A has permissions to update the schema, and developer B has permissions to create and update connectors, and those can be entirely different. Those could also be separate deployment processes. So the way that I would think about this is that you have essentially a schema deployment process where you are updating the world of possibility that connectors can consume, and then you can have a separate connector deployment policy if you want, where the client, which is essentially a pre-flight of your client deployment. So before you would release your app to the App Store, before you would deploy a new version of your web app, first you would deploy a new version of your connector. And so that can still be in control of the client team. That can still even be in the client code base. But it does require sort of this deployment and extra step, which is the same with persisted queries, which is the same with trusted documents. It is essentially pre-registering your query documents in some way, shape, or form with a server. But that can be sort of decoupled in lifecycle. So you don't necessarily have to do like a server release to do a client release. You just need to essentially have a resource that you can update that represents those trusted queries. I mean, I certainly hope. So the question was, are we really saving time, or are we just sort of like shuffling around where things go? And I mean, obviously my goal is that we've saved you a lot of time. And I think that the way that we save you time is that you don't have to construct, lots of people, right, are going to write a GraphQL schema that essentially each resolver is calling to an ORM like Prisma or something, and then just resolving with data that it gets. And then you're also going to separately have to write queries that consume that resolver that you wrote. And so it's basically rather than having to write the resolver and the query that consumes the resolver and making sure that you have types that get generated from one of those or in both places, we just sort of smush all of that together and say when you write the query, you are also resolving this data from this very flexible generated query schema that we've built for you out of the database. And so I don't think that that's been the most articulate answer, but I do think that we save you time, is the TLDR.
I'll try.
I appreciate that. Please do. All right, I think that I am slightly over, but if there's any last questions, I'm happy to keep chatting about this all day. Feel free to follow me out of the room. So thank you very much for your time.